TEKS 11B, vocabulary, and negative and zero exponent property. So we're starting the properties of exponents. So today we're going to talk about negative and zero exponent. So let's look at some notes. So let's see. We have two words. We have base and power. I'm going to go ahead and add a third one that I forgot to add, and that's coefficient. So please add these to your notes. Okay, so let's describe each of these vocabulary words. So a base, I'm going to describe as something attached to the exponent. So it's attached to the exponent. And then a power, notice that I wrote is equal to exponent. So when you think of the word power, also think of the word exponent. They're exactly the same. Or if you think of the word exponent, remember the word power. So power and exponent are the same word. And then coefficient is going to be the number in front of the base. So let's look at an example. So I have the example 5x squared. So the exponent is going to be the 2. That little number is the exponent. So this is the exponent. And then the base, remember, is attached to the exponent. So that means the base is x because it's attached to the exponent. And then number 5 has to be the coefficient because it says the number in front of the base. So this 5 is the coefficient. I'm just going to abbreviate it. Okay, let's look at one more example. Let's look at 3 times 6 to the c power. So here, our exponent is now the letter c. So I'm going to write power, because remember, power is the same as the exponent. So this tells us that the exponent can be a number or a variable. Okay, let's look at the base. Remember, the base is attached to the exponent. So in this case, our base is 6. Base. So this also tells us that the base can be a variable or a number. And then lastly, we have our coefficient. Our coefficient is 3. And this tells us that our coefficient is always a number. So in the first example, it was 5. In the second example, it was 3. So it's always going to be a number. Okay, so that's the vocabulary. Let's look at our first rule. So our first rule is going to be the zero exponent rule. And the zero exponent rule says if you raise anything to the 0 power, the answer is always 1. And this right here, this rule, says exactly what this sentence says. It says a to the 0 power is equal to 1. This is going to be on our star chart. So remember that star we're going to take at the end of the year? This is how that sentence is going to look. So we have to know that this rule is the same as this sentence. Okay, so let's look at some examples. So this says negative 3x plus 7 raised to the 0 power. Let's first find our base. So our base, remember, is attached to the exponent. So the thing attached to the exponent here is this parentheses. So that tells us that this entire thing is our base. So this entire parentheses is being raised to the 0 power. And anything raised to the 0 power is 1. So that's our answer. Okay, let's find the base in 2. It says 8x to the 0 power plus 5. So our base is whatever's attached to the exponent. So the only thing attached to the exponent is this x. So that means x to the 0 power changes to 1. So let's cross this out and write a 1. So now this reads as 8 times 1, because we have an 8 and a 1, plus 5. 8 times 1 is 8 plus 5. 8 plus 5 is 13. So 8x to the 0 power plus 5 is 13. Okay, let's look at this one. We notice here that the base is whatever is attached to the exponent. So in this case, the parentheses again is attached to the exponent. So this whole thing is going to get raised to the 0 power. So that means this whole thing right here is going to turn to 1. So I have 1 plus 2, which is 3. That's my answer. Okay, pretty easy, the 0 power. Let's look at the negative exponent power now, the negative exponent rule. It says if the negative exponent is in the numerator, move it to the denominator and make it positive. And this says vice versa. Vice versa means we can change these two words here, numerator and denominator, and it will still be the same thing. So if we do the vice versa of this, it says if the negative exponent is in the denominator, move it to the numerator and make it positive. So same thing, wherever our negative exponent is, we have to move it to the opposite side and make it positive. And this is shown by this rule. A to the negative n is equal to 1 over a to the n. This is on our star chart. Okay, so let's look at our examples. I want you to go ahead and cross off example 3 and example 4. I'm going to give you guys different examples so it matches your worksheet that you're about to do. So we're going to do 1 and 2, and then here's the new example for example 3. It's going to be 5 over a to the negative 3. And then the example for the fourth one is going to be 2 over 3d to the negative 3. Okay, let's look at our first example here. We have 2 to the negative 3 power. So since we're talking about numerators and denominators, that tells us right away that we should put our answer in fraction form. So let's turn 2 to the negative 3 into a fraction by writing it over 1. When we write it over 1, we notice that our negative exponent is in the numerator, so we need to move it to the denominator. So when we move it to the denominator, nothing is left on top except a 1. So 1 is now on top. And if we move it to the bottom, we have 2 to the third power. This is our answer here, but we can simplify it. So 1 over 2 to the third power is the same as 1 over 2 times 2 times 2, which is 1 over 8. Okay, let's look at our second example. We have in parentheses negative 3 to the negative third power. So I'm going to write this over 1. And I notice that my negative exponent is in the numerator, and I'm going to move it to the denominator. So I'm left with 1 on top and negative 3 to the positive 3 on the bottom. So this is our answer. But we can simplify this by putting 1 over negative 3 times negative 3 times negative 3, which is negative 27. Okay, let's look at example 3. Our negative exponent is on the denominator, so it's already in fraction form. We don't have to turn it into a fraction. So since it's in the denominator, I'm going to move it to the numerator. So notice that there is a 5 in the numerator. Do I need to move the 5 anywhere? No, the 5 is going to stay exactly where it is. So I'm going to write the 5 on top, and I'm going to move my a to the negative 3 on the top too. And notice that there's nothing left on the bottom, so I can just write it over 1. So that's my answer. Okay, last example, I have 2 over 3d to the negative 3. My d to the negative 3 is in the denominator, so I need to move it to the numerator in order to make my exponent positive. So notice again that my 2 and 3 in my fraction is not going to change. They don't have any negative exponents. They're going to stay exactly the same. So I'm going to write 2 over 3. It stays exactly the same. And then I'm going to move my d to the top. So it becomes d to the positive third power. And that's my answer.